Hello viewers, today we are going to see a problem based on Carnot engine. So the question is, a Carnot engine is operated between two reservoirs at temperature 177 degrees Celsius and 77 degrees Celsius. So this 177 degrees Celsius and the other one is 77 degrees Celsius. If the engine receives 4200 joules of heat energy from the source, now this is the source. So the heat supplied to the working substance is given as 4200 joules. In each cycle, calculate the amount of the heat rejected to the sink. Now this is source and this is sink in each cycle. Calculate the efficiency and work done by the engine. So we will try to solve this problem. First, the given temperature is in Celsius. So therefore we have to convert that into Kelvin. So what you do is T1 is 177 degrees Celsius. So you add plus 273, that will give you 450 Kelvin. Similarly, this sink is maintained at a temperature of 77 degrees Celsius. You add 273, you will get 350 Kelvin. So the heat energy supplied to the working substance is 4200 joules. Now we have to find out what is Q2, work done, and so on. Okay. So we have the formula Q2 by Q1 is equal to T2 by T1. So from this, Q2 is equal to T2 by T1 into Q1. Okay. Now what is T2? So Q2 is equal to Q1 is 4200 joules into T2 is 77. The 77 degrees Celsius is converted, so it is 350 by T1. T1 is 450. Now these two values are in Kelvin. Now if you simplify, you will get Q2. The heat that is delivered to the sink is 3266.67 joules. So the next step is we have to find the efficiency. Efficiency is given by one minus T2 by T1. Okay. So the heat supplied by the system source is given already, which is 4200 joules, and 3266.67 joules goes into sink. So remaining energy alone is utilized for the work to be done. So next we have to calculate the efficiency. Efficiency eta is given by efficiency eta is equal to 1 minus T2 by T1. So now next we have to find the efficiency. So efficiency is equal to 1 minus T2. T2 is 350 Kelvin by T1. T1 is 450 Kelvin. So this will result in 0.2222. That is 22.22% in terms of percentage. So the efficiency, if you see, it is not even 50%. Most of the energy, heat energy, goes into sink. Okay. Next is work done. Work done W. Now if you see this diagram, Q is the heat supply to the system. So Q1 is equal to W plus Q2. That is heat energy supply to the system. This is the input. Outputs are work done, and Q2, that is goes to the sink. From this, work done is equal to, from this equation, work done is equal to Q1 minus Q2. Okay. Now what is Q1? It is given in the question, which is 4200 joules minus Q2. Q2 is the heat that goes into sink. Just now we found out, which is 3266.67 joules. Okay. Now if you subtract the work done, you will get the work done, which is 933.33 joules. So even though the input heat supply to the system is 4200, the useful energy we are getting is only 933.33. This alone is converted into work done. So the remaining heat goes into the sink as far as this problem is concerned. Hope you have understood this problem in detail. Thanks for watching. Nandri.